My name is Ladislav Koroshi. I will present the agent optimization module, which is a new module in logistics library. As it was mentioned before, the logistics library can optimize roads, agents, and material flow in production. Here is a list of actual modules of the logistics library. I will highlight, except the presented agent optimization module, the real-time locating system, and the material flow module, because they are related to agent optimization. More about them later. What are the requirements for the agent optimization? We recommend a Linux-based PC, and of course Docker, because all modules of the logistics library are available as Docker images. The objective of the agent optimization module is to compute the optimal number of required agents for material transport. Under agent, you can imagine AGVs, humans, forklifts, and so on. The module can be used in determining equipment requirements. For example, how many forklift trucks will be required to satisfy specified flow rate after change in your material transport. The module performs static optimization based on the input data. The first is the distance matrix. It is an n by n matrix representing the distance from stations to stations. Then the flow rate matrix. It represents the material flow rate between stations for each agent type. And finally, the agent parameters as speed, capacity, availability, and so on. The input data are stored in MongoDB database. They can be entered manually using MongoDB commands. The second way is using your own application by using other logistic library modules. Our future plan is to develop an application for logistic library, which will provide this functionality. Pavel Lukács in our team will take on this role. And finally, using the material flow node, which gathers data from real-time locating system to provide inputs for agent optimization. In the next picture, the agent optimization architecture is presented. Agent optimization delivered as a Docker image contains the optimization, so this part, and the MongoDB. So they are in one Docker image. So the module can be used as a standalone without other modules. The data are stored permanently in the database, and you can access them using the MongoDB or directly interacting with the database. Let's have a small, easy example. In the right picture, we have numbered the stations from 1 to 7. On the right side, we have the distance matrix, where the first row represents the distances from station 1 to all other distances. The number 65 now represents the distance from station 1 to station 2. So from here, station 1 to station 2. Then we have the flow rate metrics for one agent. The same applies. So in the first row, we have the material flow from station 1 to all other stations. So 100 here means a material flow from station 1 to station 2. And finally, the agent parameters, as was said before, with their units. So for example, agent speed 50 meters per minute, and so on. These data are stored in MongoDB in the following form. The values are strings. The request ID is a unique ID for the computation. It uniquely identifies the dent for optimization. N is the size of the matrices. Then we have the distance and flow rate matrices encoded in one line. rows are separated by semicolon and the numbers by comma. So for example, this part is the first row in our matrix, this is the next row, and so on. Then we have a list of agent parameters. And finally, we have the optimal number of agents and the rounded value of the optimal number of agents, which are the results of optimization. They are written back to the database after optimization. The result done is used to control the computation. It is if it's value 0 at the beginning and we start the optimization, the data will be processed by the module, and after they are written back to the database, the value changes to 1. And if the value is 1 and the optimization is called, the optimization skips this computation, skip this data. To start the agent optimization Docker image, you can use the following command written here, where we have the port mapping, then we have the instance name, and finally the location for your permanent data. To interact with the Docker image, we can use the following command. So enter to bash to manually enter data. We can start the command line for the MongoDB, create the collection if they are not present. The structure is the following. The agent optimization is the name of the database, and under the agent optimization, we have the collection agent. We can use the insert1 command to insert the earlier described data. And finally, the find instruction, so command to retrieve data if they were correctly written to the database. To start the optimization, there are two ways. So first, to execute it manually in the Docker image, or we can start it outside from the host PC using the Docker command. In the next picture, we have an example of output from the module. In the first line, we can see the ID of the processed data. And at the bottom side, we have the results. So for example, the rounded number of required agents. To manually retrieve the data stored in the Docker image, you can follow the list of commands. In this picture, we have the results. So we can see the optimal number of agents, the rounded value, and the changed result done after the optimization. Of course, the task is not to enter data manually as it was described, but it's also possible like this way. That's all from me. Thank you for your attention.